Hi friends, welcome to another edition of QuickTip videos brought to you by dataplatformcentral.com. In this edition of QuickTip videos, we are going to look into a Power BI DAX tip. Today's topic is on demystifying Rankx function. You might be wondering why I have chosen this topic for today's session. Rankx has been a popular function which has been around for a while, and there have been already numerous posts and videos on Rankx. Still, I thought of choosing this topic for today's session because of my recent conversations with a couple of my colleagues. During recent times, there have been at least more than one occasions where I have been asked a question on Rankx from multiple colleagues. This made me understand that though people have been using this function for a while, the complete use case of this function is still foreign to many of these people. Particularly, I am discussing about the third argument in the Rankx function. If you refer to the syntax of Rankx function starts with the first argument, which is a table, followed by an expression, which is an expression based on which usually ranking takes place. This is the common use case of Rankx that all of us has used. But if you see, there is a third parameter called value, and nobody really knows, or at least the people that who have asked me, they were unaware of what this parameter value is doing inside Rankx. If you search for this, you will get very little documentation, and even the documentations you could find is not really clear on what exactly this value is doing inside Rankx. So this is one of the use cases that will be covered in this session. And there is one more use case which people have been asking. How can you write the Rankx DAX expression in such a way that you can apply a ranking within a group? So you might have a category field, for example, inside your data where you have multiple categories and you have multiple rows of data coming under each category. Say let's take the case of sales, and you have a category like say sales region. And you have regions like Asia, you have Australia, you have Pacific, Southeast Asia, and you might have a sales data coming for each of these regions. Now the requirement is for you to get the top 5 customers for each region, which means that you are going to apply a rank, but the ranking has to be applied within each of the sales regions separately, so that you get the top 5 out of Asia, top 5 out of Pacific, top 5 out of Americas, like that. And I've seen many people struggling with requirements like this to apply ranking over a category, so that the rank is calculated separately within each of these category groups. So this will be another use case which will be covered in the session. So let's see how these two use cases can be handled by applying the Rankx DAX function. For the sake of this demo, I'll be using SQL Server Management Studio for executing the DAX queries. If you had followed my earlier video on XML endpoints, you will know that you can use SQL Management Studio to connect to your Power BI model by using its XML endpoint, and you can analyze the data by writing DAX queries against it, which means that you can effectively use SQL Management Studio just like DAX Studio for analyzing the data by executing DAX queries. So we will be using SQL Management Studio for the rest of this edition to execute this DAX queries. To start off, let's look at this derived table query where I am creating a summarized view of sales data, particularly the revenue measure, by means of grouping by brand name and category name. If I run this query now, you will see that the query returns the unique combinations of brand name and category name, and it will return the current year revenue and the previous year revenue for each of the brand and the category combination. Like Electra children bicycles, you have the current value and the previous value. Similarly for Harrow bicycles, Electra comfort bicycles. So every combination of brand and category, you will get the current year revenue and the previous year revenue. We will be using this query as the base, and then we will be applying a ranking on top of this to calculate the ranking corresponding to each of these data rows. So let's start off by using a simple ranking query. So I'm going to use the add columns function to add the ranking column to this query. So I have added two columns here. One is by applying Rankx on this derived table which I have stored inside a variable on the top, which makes use of the summarize columns to summarize the data from sales order items, which contains the sales data based on brand name and the category name. And I am calculating revenue for the current year and revenue for the previous year. So what I am doing here is, like, on top of that I am using add columns, and I am adding two columns, rank and rank compare this year, two ranks. If you see the expression I am using for the ranks, both of them are using Rankx. But the difference is that in the first case I am applying Rankx, the first parameter is passed as the table name, which is as expected. The second parameter, which says expression, I am passing revenues. That means I need to rank it based on revenue, and I am not passing the third argument, and I am passing the fourth argument as the descending order. So I want to rank it based on the descending order of revenue. This is the usual way of using Rankx function. Now if you see the second expression, which says rank compared to this year, I am actually passing a value for the third argument as well. So this is where the third argument value is getting passed. This is not a common scenario that people usually come across, and many people doesn't know what happens when we pass a particular value for the third argument. So here I am passing the previous year revenue as the third argument, and let's see what happens when we pass the previous year value as the third argument, and all the other arguments are the same. So the expression corresponds to the revenue of this year, and the order corresponds to descending order. And I am just putting an order by to make it evident to the users, like what exactly is happening. So when I order by that, the result will automatically be ordered by the particular field. So I am ordering by the rank here, and so let's see what happens. Okay, so let's now execute this modified query, which consists of these two additional columns. One will be the rank, another one will be rank compared to this year. So as expected, we have got the result set with the additional columns. Now let's look into the value for each of the additional columns. So what we have applied is, like, if you see, we passed the entire table as the first argument, so the ranking will be applied on the entire table in this case. Now if you see the first value that gets generated for the first column, which is the rank column, it is as expected. So the highest revenue column will get the first one, the next best revenue will get the second, and like that. This is expected result set based on the Rankx function. So the highest one gets 1, the next one gets 2, like that, up to the 14th one, and then all the others doesn't have a value, so all of them will get 15. So this is the expected value. Now let's look at the rank compared this year. So what exactly happened here? So the difference between these two columns are that in the first case we didn't pass a value for the third argument. In the second case we passed a value for the third argument as previous year revenue, and we also have the previous year revenues shown here. So in the second case, what exactly happened? So what happens is that when you pass a value for the third argument of the Rankx function, that value will be used as the reference value to compare against all the values returned for the other rows as specified by the second argument. So in this case, what will happen is that for every row, when it tries to, because Rankx is a row iterator, so it will iterate through every row and try to calculate it. So for every row, what it does is that it will take the previous revenue value for that particular row, and then it will compare to the revenue values of all the other rows. In the first case, because we didn't pass any value for the third argument, it will always compare the revenue value against the other revenue values. In the second case, it will compare the previous year revenue value for the current row towards the revenue value of all the other rows. So let's see what happens in this first case. If you see the first value, it is 17,355, and the ranking that we got for the second case was 4. How did we get this 4? So for that, when it takes this particular row, it will take the value corresponding to the previous revenue for that particular row, because that is the third argument that we passed. So that means it will consider 17,355, and it will compare this 17,355 to every other values of the current year. So that means it compares 17,355 to 2805, 29,497, all the other current year's value will be compared against this value, and it will find out at what position this value can be fitted in. So when you try to compare it, first it tries with the current value for truck, which is 29,497. It is less than that, so the first position will be going to 29,497. What is the second position? Second position is going to 2871. It is again greater than this, so the second rank will also go to the 2871 itself. Now let's go to the next one. What is the next highest value? It is again 20,036. So the third one will go to that. Now look at the fourth value. The fourth value is 12,342. This is less than 17,000. So when you try to fit 17,000 within these, it can be only fitted this particular position, which means that 1, 2, 3, fourth position. So that means if 17,355 was the value which was used for comparison for trek mountain bikes, it will get the fourth position. So that is what it will return as the rank. That's why we are getting 4 here. Now we can go to the second row. Now when it tries to calculate it for the second row, instead of 17,355, it uses 12,582 to compare to each of these values. 12,522 is less than this, so this will get 1. 12,522 is less than this, so it will get 2. 12,582 is less than this, so it will get 3. 12,582 is greater than 12,342. So again it can be fitted at the fourth position. So that is the position that it will return. So it will again get 4. Now go to the next one. So for the next row, if you see, the value is 53,810. It is greater than the first value itself. So that means this value can be fitted in at the first position. So it will get the rank as 1. Again look at 17,159, which is less than this, less than this, less than this, but greater than this. That means it can be fit at the fourth position. So it will again return the 4 as the rank. Now for the next one, there is no value. So then for that, when it tries to fit it, it has to come after all these values. So we have how many values? From 1 to 14 we have values. So after that, when you try to put it, it will get 15. Again 13,903, when it tries to put it, it will find that it is greater than the first value itself. So it can be put at the first position. So you will get 1. Like that, for determining the comparative rank, it will use the value which is passed as the third argument as the reference value, and it will compare it to every value of the expression which is passed as the second argument. So in this case, it will take the previous value of that row, compare it to the revenue values of every row, and find out where exactly this previous revenue will be fitted in, and that is the rank value it will return. Now so far we have been finding out the Rankx over the entire table. So if you see the Rankx, we are passing the table as it. Now comes the next use case. How can you apply the same logic but for each of the category rows? So if you see that in this case, you have the brand name. There are different brands coming. There is a brand called Trek, there is a brand called Electra, then there is a brand called Harrow, then Sun Bicycles. What if we want to find out the rank separately for each of these brands? The query for this use case looks like this. So what happens here is that instead of directly passing the table name, what we do here is like, for example, let's look at the case of the rank column. First we will declare a variable called brand, and we will use product brands brand name to set a value for that, and then we put a return clause inside the main return, and there when we apply the Rankx, we use this variable to compare the value of brand name against it. So what will happen is that when Rankx, because Rankx is a iterator function, when it tries to apply the Rankx, what it will do is like, it will check what is the current context brand name. That current context brand name will get stored inside this variable, and that will be used for comparison against the whole table, and whatever rows whose brand name matches this brand, which means all the rows which are matching the current brand name under consideration will be taken while it applies the Rankx, and it will apply only to that subset of rows this Rankx, and the rest of the logic is the standard logic which is applied by the Rankx. On top of it, it ranks based on revenue. And in the second case, again we are applying the same logic here. We will get the current context brand name into a variable. We use that to take a subset of rows whose brand name matches to that, and on top of that we will apply the Rankx by passing the comparator value, so that it use that value to compare against the each of the current year revenue values. Now if you run this, you can see that, and you can, to make it more easier for the users to understand, I have also added a order by brand name and rank, so that it comes for each brand what was the ranks. It's easier for us to follow. Now if you run this query, you can find that each of the brand name comes together, and for each of the brand name you will get all the ranks from 1 to whatever. See, for Electra you will get 1, 2, 3, 4, and again for the next one Harrow you will get 1 and 2. So the ranking is calculated separately for each groups of brand. This is because of that variable that we used to store that current context brand name, and then use it to filter the existing table to get only a subset of the table which belongs to that particular brand. Now here also, if you see, the first rank is based on the value alone. For Electra, if you see, the highest value is 20,871, it will get 1. The next one is 20,036, 2. Next one is 12,003, and then the next one is 2016, which will be 4. Now if you go to the second comparative rank, you can see that it compares 12,582 to each of these values. So 2871 is greater than that, that will get 1. 2336 is also greater than that, it will get 2. That the third value is less than this, so it will be placed at the third position. So the ranking returned will be third. Similarly, 53810, that is the highest value, so it will be placed at the first position, so it will get 1. And 17159, again the first two are greater than that, so it can only be placed at the third position. So the ranking that will return will be 3. Similarly, if you see the Trek, you can see that first value is 17355 when compared to 29497, it is 29497 is greater, so it will get first. Next one is 4000, which is less than this, so it can be placed at the second position, so you'll get 2 as the second one. And now for the second row, you don't have a value here, so it can only be placed at the last. So there are 1, 2, 3, 4, 5 values, it will be placed at the sixth value, so that's why you are getting 6. And when it comes to the third row, you are getting the value, the comparator value as 30,903, and when you compare it to the first value itself, it is greater than that, so it can be placed at the first position, so the comparator rank will be 1. So like this, it will calculate it within each of these brand groups. So I hope you understood how the Rankx function can be applied in both of the use cases. In the first case, it's just a matter of passing the third argument, where you need to pass the correct comparator value, which is the previous year revenue value in this case. Whereas in the second case, for getting the corresponding ranking for each of the brand groups, you have to apply the context, the current context value, you need to store it somewhere and use it for comparison while you are applying the Rankx, so that you are only applying the rank on the filtered table, which consists of the brand names having the same value as the brand in the current context. So that is what you achieve by applying this additional variable declaration inside and using this return variable. So hope this quick demonstration helped you to understand how the third argument of Rankx function works and how it can be used for applying a ranking with respect to another comparator value. Also, we understood how we can apply ranking on a grouped basis, so that based on the category groups available within our data, we can apply the current context based logic to get the corresponding value for the category group and use it to filter the main table to apply the rank only to those rows which applies to the category grouping. Hope you find this video useful. As usual, keep sending your feedback, keep following my videos, subscribe to my channel for getting useful videos like this, and click on the bell icon for getting notifications in future. Meet you all soon with another useful tip like this. Till then, bye and have a nice time.